Hey everyone, welcome back to Stats and Stuff. This is Taylor, and we are finally going to dig into how to work some problems using the normal distribution. Now, to do this, we are going to follow a 4-step process that I use every single time I work a normal distribution problem. In fact, we use it when we work sampling distribution problems later. It is a very, very useful kind of framework to put these types of problems in. So we're going to walk through that in just a second, but I want you to know that basically the rest of the time that you watch this channel and we're working a normal distribution problem, this is how you're going to see me solve it. Okay. So, take some notes, write this down, and let's kind of dig in. So the first step of this normal distribution framework is that we are going to draw and label our graph. Now, this is a step that people always want to skip. And so I'm going to write over here, draw and label graph always. And always is going to be in all caps. Because it's one of those things that you feel like you can just like skip over. Like, who needs to draw a graph? I can do this in my head. Draw the graph, right? Do it. I have a PhD in economics and I still draw the graph every single time. Okay? It's helpful. It just prevents you from making mistakes. Do it. All right, so we're going to draw and label our graph. Secondly, what we're going to do is we're going to calculate z-scores. I'm going to work a problem in just a second so you can see what all this means. I'm just giving you a second to kind of get this in your head. We're going to draw and label a graph. Then we're going to calculate z-scores. Then we're going to look up those z-scores on the z-table. Now, what this allows us to do is find the area under or between particular points on the normal distribution. So we want to look up z-scores on a z-table. And then finally, use the area from number 3, what we get out of the z-table, to find the area we actually care about. Okay. We are going to use this every single time. Draw and label the graph, calculate the z-scores, look up the z-scores, find the area we care about. That is the process of working a normal distribution problem basically every time. Okay? Little things will change here and there. The way that we look up the z-score might change. The way that we do step number 4, which kind of I write it kind of generally, but you'll see it's very kind of step by step. And if you draw the graph, it's very obvious what you should do in every step. Okay, if you've got the steps and you draw the graph, things become very, very obvious. Okay, so let's take a look. So let's say we have a normal distribution. All right. Here's a normal distribution. Let's go back to our handy dandy IQ test. So we have an IQ test that's normally distributed with a mean of 100 and a standard deviation of 15. So let's write in our mean of 100. And we've got our standard deviation of 15 up here. There's nothing really draw there. Okay? And let's say that we want to find the probability that someone who takes the test, X, the score that they get on that test, that's what our X is going to be. So say that score is greater than 130. So this is the thing that we want to find. What is the probability that the score that someone gets on a test is greater than 130? Right? How in the world do we answer this problem? Okay, well, what we have to do is recognize that anytime we're getting a question about probability in the normal distribution, well, in any probability distribution for that matter, when you hear the word probability, you should think of the word area. Because in the normal distribution, the area under the curve is equivalent to probability. Okay, so very early on when you were learning about probability distributions, you might have heard the statement that the area under the curve of any probability distribution, the area under the curve is 1, right? Because something has to happen, right? If you take the test, you're going to get a score. Okay, so it's going to happen. The probability of something happening is 1. Okay, and so the way that we find the probability of the score being bigger than 130 is we find the area bigger than 130. So again, when you hear the word probability, think in your head area. I used to make my class literally chant probability equals area equals probability. I'm not going to make you do that. It'd be weird if I kept doing it, but I used to do that all the time, and it just sticks in your head that probability is equal to area. So what does that mean? This is what we're going to label. We know that 130 is to the right of 100 because, numbers, that's the way they work. So we're just going to stick it over here. Is that where it's really supposed to go? I have no idea. Okay, but I don't really care. This is not to scale in any way, but we're going to put 130 here. So what's the probability that a test score is greater than 130? To find that, we want to find the area greater than 130. So what I do is I shade that area. Okay, I need to find the area that I just shaded. If I can find that area, that is equivalent to the probability that X is greater than 130. Okay, so what I really want to do is find the area greater than 130. So how do I do that? Okay, this is where we start using our 4-step process. What we just did here, this is step number 1. We drew and we labeled our graph. Okay, you're going to do this every single time. So this area here is the thing that we don't know. Okay, this is what I want you to start with every single time that you work this problem. Step 2 is calculate a z-score. Okay, so what we're going to do is we need to turn this 130 into a z-score. Well, how do we do that? Well, we use the z formula. Z is equal to x minus mu over sigma, right? Which in this case is 130 minus 100 over 15. Remember, our standard deviation is 15. It told us that earlier. This is 30 divided by 15, which is equal to 2. Okay? Now, so that means that our z-score, I'm going to come label that down here, z is equal to 2. Okay? 130 is 2 standard deviations above the mean. That's what the z-score tells us. Okay? Now, why do we need that? What in the world does that do for us? Well, when we are trying to find area, there's a thing out there that has been given to us called a z-table. Now, there's a lot of ways to come out and find this area. Okay, but one of the ways that we do that, and the way that I'm going to show you how to do it, is to use something called a z-table. And the z-table is basically a big table of z-scores and areas. It says for this z-score, this is the area, and then what area it gives you is sometimes different. Usually, I would say like 75% of the time, it's going to give you the area to the left of that z-score. Okay? So if you go look up, for example, a z-score of 0, right? That would be here in the middle, right? 0 standard deviations away from the mean. Literally, the mean has a z-score of 0. What is the area to the left of that? Well, it's 50%. How do I know it's 50%? Because the normal distribution is symmetrical. If the total area under the whole thing is 1, then you have to get 50% on one side and 50% on the other. Okay? So what we're going to do is we're going to go look up a z-score of 2, and we want to find the area to the left of 2. Now, that's not the final step. That's not the thing that we need to finish the problem, but it will get us there and almost there. Okay, so what we're going to do is we're going to go look at a z-table. So let me go pull up a z-table real quick. And what we're going to find is that on our z-table, we want to find the area to the left. So the easiest place that I'm going to go is ztable.com. Okay, ztable.com. And if you go look up in this z-table, you need to find 2.00 because that is our z-score, 2.00. And if you go look up 2.00, what you will find is that the area to the left is 0.9772. So the way that I show this is I draw a little kind of arrow here, and I take it all the way out this way. And I say that area is 0.9772. Okay? If you have a text, like a stats textbook, usually that z-table is back in the appendices of the stats text. So really close to the end of the book, right? So you can see which one you're using there. Again, ztable.com is another one that I like to use. If you go look up z is equal to 2.00, you'll kind of have to triangulate it in this table. You will find that the area to the left of that is 0.9772. All right. So what I'm going to do is I'm going to draw that area in blue. Let's use red. Let's use red because you can better see red a little easier. So the 9772 is this area here. It's all the area to the left. Now, you don't have to do this when you're drawing your picture. Just drawing this kind of arrow up at the top is fine. But for what we're doing today, this is probably going to help understand. Okay? The area to the left of 130, the area to the left of a z-score of 2 is 0.9772. That's step 3. What we just did is step 3. Go out and look up our z-score in the z-table and see what the area to the left is, right? So that was step 3. So let me just kind of come up here. I'm going to label that step 3, what we just did there. Finally is step 4. How do we use that area to find the area that we care about? Okay. To do that, we need to, depending on what this looks like at this point, you're going to do one of 3 things. Either the area you just found is the area you care about, and at that point, there's nothing left to do. You're done. Okay? But in this case, that's not the case. We found the area to the left of 130, and what we really need is the area to the right of 130. Okay? So to do that, what we have to remember is that the area of the whole thing is 1. Oh, you can't see that down there. Is 1. The area of the whole thing is 1. And so we don't care about the red area. All we care about is the white area. And so what we're going to do is we're going to take the entire thing, which is 1, subtract off the stuff that we don't care about, 0.9772, and it is going to leave us with the area that we do care about, this white area. So let me just kind of draw a line here so we don't get these two things confused. And so the question mark, the thing that we're trying to actually solve, is 1 minus 0.9772, right? The whole thing minus the part that we don't care about leaves us with the part that we do care about, which is 0.0228. So what is this white shaded area here? It is 0.0228. And then I always like to circle that so that we know where our answer is. So we're going to do those 4 steps every single time that we work a normal distribution problem. Draw the graph, calculate the z-score, look up the z-score in the z-table, find our area. Those 4 steps will always allow us to solve the problem. Okay. Now in the next set of videos, I'm going to work through these problems. I'm going to do about 3 or 4 examples in each video and show you how to work them. Follow along with me, work them as I do. And then in the description, I will put a link to some study guides that has about 10 problems each that are fully worked out if you want to download those as well. So I've got a lot of resources here to help you understand this, because this is one of the most important things that you can kind of learn how to do, because this sets you up for essentially this is the foundation of all statistical inference that comes later in these kind of classes. Okay, so really learn how to do this, and it's going to make the rest of your class that you're in a lot easier. Thanks, guys. Like and subscribe. Really appreciate it, and hope you have a good rest of your day. Thanks.